The overall goal of this experiment is to use a 3D printer to fabricate particles of a wide variety of shapes and measure their motion in a turbulent flow.
This method can help to answer key questions in fluid dynamics, such as how particles rotate and align in turbulent fluid flows. Its main advantage is that it allows for precision, time-resolved measurements of the orientations of particles with complex shapes that could not be achieved with previous methods.
This method has provided insight into the motion of disks and spheres in turbulence and can be used to measure the dynamics of particles with complex shapes in many other situations.
Generally, individuals new to this method will struggle with 3D camera calibration and adapting the orientation finding algorithm to specific particles being used.
Helping to demonstrate the procedure will be Guy Marcus, who performed the original experiments with crosses and jacks.
Begin by using computer-aided design software to create particle models for printing. To create a triad using AutoCAD, first use the circle command to draw a circle with a diameter of 0.3 millimeters. Then, use the extrude command to make a cylinder 3 millimeters long. Cylinders of this size are the building blocks of the particles. Now, use the rotate command and select the axis of rotation to be along the x-axis and the rotation angle to be 90 degrees. Adjust the view to allow room to work with other cylinders. Next, make a copy of the cylinder that will be the second arm of the triad. At the end of this cylinder, apply the Rotate 3D command with the axis of rotation along the z-axis. Rotate the cylinder 120 degrees for the triad. Move the rotated cylinder into position to form an arm of the triad.